today we are gonna see the circuit diagram of domestic 3-phase house wiring. So in this case we know that, as we have seen in our earlier video, that is of single phase connection. So here similarly we have a pole. So we know that from pole we get 4 wires, that is R, that is first phase, R phase, and Y and B, that is this is a combination of 3 phase, and neutral, we all know that neutral is common, so it is connected to a meter. Generally we see meter of 8 pins, that is R, Y, B and 3 neutrals, that is 6, and output other 8 to 16 pins. But in this case we have seen only R, Y, B and neutral is common, so there is only one input and other output. From here we 2 wires go to the main house distribution box. Okay, so in this case, and also we know that the combination of R, Y and B is 415 volt without neutral. It is without neutral current. The combination of 3 phase is 415 volt without neutral, right? It is because it contains 120 degrees angle from each of the phase. So this in this case it leads to no neutral, and due to its 120 degree angle we find that the 3 phase combination current is 415 volt, whereas if we see the pair of R and N, it is 220. Similarly Y and N, it's 220, and blue and neutral, it's 220. That is because the potential difference across each phase separately is 220 volts, and when it comes to neutral it is 0 volt. That is nothing but the phase wire brings the current and neutral wires takes it back, right? Okay, so now let's come to the meter. As we have seen that meter, I have said that different types of meter comes. So then meter goes to the distribution box. Here is the main role of your house. Okay, so we have 4-pole MCB. 4-pole MCB is nothing but either you can use the isolator or MCB. So difference between them is isolator doesn't trip, it is just in the case for on or off, whereas MCB, it is used for short circuit and overload protection, right? So 4-pole MCB is used for 3 phase and neutral, that is R phase, Y phase, blue phase, and neutral is for all the 3. So in this way we can connect it anyways, whether this comes this or here, no worries. Okay, so it is nothing but the input comes and the output goes to different phases. Now if we see here, there are total 2, 4, 6, 8 MCBs, right? So from 8 MCBs we can find that 2 are given R phase, okay, 2 are given as Y phase, and other 2 are given as B phase. Remaining 2, either they are for inverter or they are for separately for neutral also, but we generally don't consider a separate single pole MCB for neutral wire because it may be dangerous and return phase may come on the sockets. So that is the case. So as we have seen that this phase is divided. Also in the apartments and buildings we find that if there is on a floor, if there is 3 flats, so R phase goes to a single flat, Y phase to the other, B to the third flat, right? In this way. And in this house wiring also it's same like that only, and then these wires through pipes inside walls goes to our respective socket. In this case we have only of rooms, so just so based on this switch this turns on. So these MCBs not only focus on different rooms, but they are also based on ampere, such as 6 ampere, 10 ampere, 16 ampere, 25 ampere. This is because based on the rating of the applications or appliances which we use in our home. For example, a bulb and a fan or a normal socket takes only 6 amps current, not more than that. We can use light appliances like light, fan, small any appliances, hair dryer, laptop charging, computers, desktop speaker, etc. but the appliances which need 16 amps current is AC, our geyser. So AC, geyser and heater, iron boxes, any high power amplifiers, etc. So in that cases we use different MCBs. So in this case also we find that 20 amps MCB is for AC, for other it is 16 amps, here 20, again 10, 10. Okay, so based on division of load we calculate MCBs. So this way the switchboard is there. For example, this switchboard contains R phase, and in the same room we find a power socket. We find a power socket for AC that may contain Y phase in this case, and in the same room if we see a separate point which is not used, we may find blue phase. So that is based on the division of load which we can decide based on the house wiring. So for 3 phase generally there are 3 wires only, and the neutral is common. Also we find some 3 phase motor starters which do not need required neutral, they run directly on the combination of 415 volts, that is of 3 phase system. Okay, and earthing is common, as we all know that earthing is common for everything. If you use whether single phase or 3 phase, earthing is mandatory, as I said in the last video that it reduces the potential difference to 0 and save human life. Then this is the wiring main thing, the indications, and general knowledge is supply voltage is 3 phase 4 wire, that is 1 neutral and 3 different phases, 415 volt AC, 50 hazard hertz. System is 3P plus N plus E. So it is in the case of 3 phase plus neutral plus earthing, and remaining all are same. So this is the general diagram. Okay, thank you.